Hello and a very warm welcome to our Cython lesson. My name is Dipankar, and in this first introductory video, I will share with you the basics of Cython. In this part of the video, I will share with you what is Cython, why we should use it. We will talk about Cython compilation pipeline, then we will talk about some common usage scenarios and how to install and set up Cython and related dependencies. Then we will look into a demo and we'll look into the performance differences between Cython versus pure Python. And then finally, we will talk a little about can Cython always help us for our benefit. So let's get started. So the first question is, what is Cython? So Cython can be seen as a programming language that extends Python and enables Python to use static type system of C and C++. It can also be seen as a compiler, which converts the Cython source code into efficient C or C++ source code. This source code can then be compiled into a Python extension module or a standalone executable. Then these modules can be used in the pure Python to do whatever you want to do. Almost all the Python code is a valid Cython code. So you can directly copy your existing Python code into Cython and then compile it to get some boost in performance. But why use Python? Well, Python brings the benefits of compiled language to an interpreted language and speeds up the Python code. With Cython, it feels like there is ease of Python with the power and speed of C++. To understand it better, we need to understand the interpreter and the process in which your code is executed on your machine. So once you write your code and click the run button, there is a compiler inside the interpreter that converts your source code into an intermediate bytecode. Don't get confused with this word compiler. This is a different kind of a compiler which converts your source code into a bytecode. And then this bytecode is executed by the Python virtual machine line by line. Since this happens on the fly when you are executing it, this conversion and this line by line execution takes some time, which makes Python a slow language. However, if we compare this with the block diagram of this compilers, the usual compilers for C and C++, they take the source code and they convert it into a machine code. This machine code can directly run on the architecture, and it is very fast as compared to the interpreter. However, the downside to this is that these machine codes are dependent on the platform, and you cannot run the same code on different platforms. However, in the case of interpreter, you can write on one platform and can run on another one. But this compiled code is very fast. And in Cython, we make use of this feature of these compiled languages. So also, Python is a dynamically typed language, which means we don't need to explicitly declare the type of variable. Python determines it automatically for us. While this makes it very easy for us as a programmer, but it makes Python a very slow language. One of the primary reasons for Cython to yield such impressive performance boost is that it brings static typing to a dynamic language. So by introducing these factors, Cython actually empowers you to make your Python codes fast. So next is to understand the Cython compilation pipeline. So the compilation process in Cython is a two-step process. In the first step, your Cython code is converted into an equivalent, optimized, and platform-independent C or C++ code. And then from there on, in the second stage, the C or C++ source code is converted into a shared library using a C or C++ compiler. However, this shared library is platform dependent. The shared library has a .so extension on Linux or Mac OS X, and in Windows, these have PYD extension. Here you can see at the top, these are the two commands that you can execute to perform the two steps of Cython pipeline. The first command, Cython hello.pyx, converts the hello.pyx into a C code, and then the second line with a lot of flags, this converts it into a shared object library. However, we will see later that we don't need to remember all these flags, and we have a much simpler setup code that do it for us. Now let's look at some usage scenarios. So we can use Cython whenever we need to optimize our Python code for speed. Usually the functions that involve a lot of mathematical operations and loop iterations are good candidate for this. There can also be situations when you already have an existing C or C++ code that needs a Python interface. In such a scenario, we can use Cython to create a wrapper for our library. So let's now see how we can install Cython compiler in dependencies. So at the top, you can see uh, we need the build essentials. This will give us the GCC compiler. Then we need a Python virtual environment. This is not really necessary, but it is always good to create your new projects in a separate virtual environment so that different dependencies don't conflict. Uh, then this is the core of it. The pip install Cython. This gives you the Cython compiler. Then you might also need IPython and Python 3-dev. So by following this process, you can install Cython. Some of these dependencies you might already have on your system, but I have noted down everything here for the sake of completeness. So Cython versus pure Python. Here you can see on your screen, I have two codes. On the left is a code written in pure Python. On the right is the Cython version of the same code. Both these codes generate a prime number. You need to give in the number of the primes. So for example, if I supply 10, it will give me first 10 prime numbers. Here you can see on the left, there are no statically typed variables. However, on the right, you can see that there is cdef int p. But other than that, this whole algorithm for generating these primes is same. There is one more difference, that here you have an empty list, but here you have an array. But other than that, these are both same. So let's now look how these two codes perform.
So here you can see the code that computes the prime numbers, and we need to compare which one of these codes does it faster. But before we compare the speed, we need to compile the Cython version of the code. In order to do that, I have this small script here. As I shared with you earlier, this compilation process is a two-step process. This script takes care of it. And we can run this script in the terminal by running this command python setup.py build_ext -- in place. Now, as you can see on your screen, I have the shared object file with me. Now let's see how we are going to compare the speed. So there are various benchmark testers and various profilers that you can use to precisely measure which part of the code takes how much of time. So here we are using timeit. It's a module with Python which allows us to do this. So here you can see in the line number 3, we are passing it this function primes from our prime_Cython shared object library, and here in the setup we are importing it, and here is the number of times we want to run it. Similarly, for the Python code, we are going to import it and run it 10,000 times, and then we are going to compare which one is faster. So in order to do this, we need to run Python timing. So here you can see Cython is 13 times faster in doing this task. All thanks to its statically typed variables and compiled code.
So we just saw that Cython can be many times faster than Python. But can introducing Cython with our Python codes always help us? The answer is no. Well, when operations are CPU bound, meaning all the runtime is spent manipulating a few values inside CPU register and little to no data movement is required, Cython has very high chances of improving the performance by introducing statically typed variables and shared object libraries. However, it cannot help when IO-bound operations like reading a large file from disk or network-bound like downloading a file from an FTP server is the bottleneck. So while selecting Cython or introducing Cython libraries for your Python codes, you first need to profile your code and look for the kind of bottlenecks that you have. I hope you enjoyed this video and learned some things about Cython. So that's all for this part. In the next part, we will dig deeper.